welcome to today's Uplink. My name is Mark Phillips. I run business development at Helium. If you've ever joined us on one of these Uplinks before, thank you very much for your time again. And if you're new to the community, thank you for joining us. I hope you will find this a good use of your 30 to 45 minutes. So a quick sort of agenda here. I'm going to do a very brief Helium introduction. Most of this is going to be focused on the Equilibrium Point team, and that's for the best because their stuff is extremely interesting. So I'll do about 5 minutes on Helium, and then I'll kick it over to Graciela and the team at Equilibrium Point, let them introduce themselves, and off we go. So if people have questions, certainly put them into the chat here in Zoom. We've got a team. Emily and McKenna are monitoring that. I'll keep an eye on it as well. We will try to take some questions during the course of this conversation, but if we don't get to all of them, which we undoubtedly will, we will miss some. We'll try to get them at the end of the conversation. We'll have about 10 minutes left over for that. And then if we don't get your question there, you can either email me or the team at Equilibrium Point. They will put their information up on the screen, and I'm more than happy to talk to you. So with that, let's get into it. So we're talking to Equilibrium Point, 3 members of their team who they'll introduce themselves in about 2 or 3 minutes. My name is Mark Phillips, head of business development at Helium. I've been here for 7+ years, and I have the pleasure of dealing with sort of all parts of the network, the coverage build out, the blockchain technology piece, and then what we're going to talk about today, the sort of utility and sensor side of the network, which I think most people will agree is probably the most interesting and arguably the most important piece of the network moving forward. So a bit about Helium, just some general background for those of you who might be new. So we were founded in 2013 with a mission to make decentralized wireless networks. And so we started with LoRaWAN, and we're going to be talking about a LoRaWAN use case today. If you looked at any news recently, you've seen that we're moving into things like 5G. The brilliant thing about the Helium blockchain is that it's sort of radio layer agnostic. And so there can be, it looks like someone's drawing on my screen. Hopefully you're having a good time. There can be any sort of wireless layer can be decentralized using the Helium blockchain. And again, we're going to be talking about LoRaWAN today. So we've raised about 53 million in venture to date from companies like Coastal Ventures, FirstMark Capital, GV, and then most recently Multicoin Capital and USV. And they're all firmly behind this mission to build this decentralized wireless network. And we're going to talk about one of the newer use cases on that network today, Equilibrium Point. So I want to kick it over to a few publicly available resources, and I think people are going to see my screen here. And if you can't see my screen, certainly let me know. So the best way to learn about Helium is through what's on our various sort of web properties, right? So explore.helium.com. This is going to give you the most up-to-date and deep sort of look at what's happening on the network. So this is all public data as sort of visualized by our team on Explore. We've got all sorts of stats here around hotspots and hotspot growth, what the blockchain is up to, what the consensus groups are doing. And then probably the most interesting thing is sort of the coverage growth here. So you can look at a full map here and dig in on cities and countries. We are, I think let's take a look at how big the network is and how big it's growing. So about 42,700 hotspots have been deployed to date. That's in the last 18 months. The growth rate is pretty ridiculous, right? So we've added 12,800 in the last 30 days alone, which is pretty wild. We're in 5,100 cities and 7,500 countries. So we have what is essentially the largest contiguous wireless network in the world, certainly the largest public LoRaWAN or LPWAN network in the world. LPWAN is low power wide area network. So there's a remarkable amount of data here inside of Explorer. This is all built on public APIs. I would highly recommend people spend some time on explore.helium.com. If you want to look at some actual coverage, you can go to mappers.helium.com. And so the community has a fantastic mapping program it's run by a guy on my team. His name is Kent. And they coordinate in Discord. So if you're not part of Discord, the Helium Discord, I definitely recommend that you go there. And so what you're seeing here is data that's actively being mapped on the network. So if you don't see any coverage, that doesn't mean there's no Helium coverage. All it means is that no one's actually been out there doing mapping with a sensor that talks to the mapping API. But you can dig around and see some fantastic coverage areas. Los Angeles, for example, which is notoriously hard for RF and massively sort of sprawling, has fantastic Helium coverage. There's a handful of groups that are deploying really, really good coverage in Los Angeles. And we're starting to see more and more cities like this, and not just big cities, smaller cities, pop up with what is extremely resilient, sort of cellular level reliability from an LPWAN network, which you just, even 6 months ago in Helium, you didn't see. You certainly won't get that in any other LoRaWAN network. So we can look at Los Angeles, that's a huge one. I always like to look at Pittsburgh, for example, which has a remarkably active Helium community. These are fun too, these little trails here. These are people who are mapping, and this one actually looks like they drove, I think. You can find some flights, which is pretty fun. Actually, this might be a flight. This is someone flying. Mapping on a plane, of course, is cheating, right? Because LoRaWAN will just continue to go and sort of always find a piece of the hot network to connect to. And so this is Pittsburgh. Pittsburgh is a really good example of, a smaller city, not to knock Pittsburgh at all, but smaller than something like Los Angeles or Chicago, that has excellent coverage, right? There's a bunch of groups and individuals that are doing really, really good work out there deploying Helium coverage. And we're now starting to see sensor deployments out in Pittsburgh, and they just work, right? Because that's how the network operates. And so lastly, before we kick it over to the team at Equilibrium Point, I did want to note that if people are interested in deploying coverage, the best place to go to is helium.com/mine. Helium Inc. does not sell hotspots anymore. This is the original one, but we do list all the approved manufacturers here on this site. So if there's an approved manufacturer by the community that has a piece of hardware for sale, you will see it listed here. Eventually, this will end up on the DY site, which is the alliance, the decentralized wireless alliance that sort of governs and operates the network. But I would say start here for the options to join the network and officially start mining HNT and providing coverage. We will have, I think there's another 6 or 7 or 8 manufacturers, 2 or 3 of whom have been approved and don't have a product in the market yet, and then another 5 or 6 that are actually in the queue about to be approved. So always like to note this, to make sure that people are looking at the correct sort of official approved hotspots for the network, because there can be some confusion about that. Okay, all right, Grass Island team, are you ready for me to kick it over to you?
Sure, we are here. This is Grace. So welcome everybody to our webinar. I will start sharing my screen now, and we will have some presentations here. Can you see my screen now?
Let's see it. There it is. We see it.
Okay, perfect. So my name is Graciela Kravtsov. I'm CTO at Equilibrium Point IoT, and I will be doing a demo for you today.
Hi, everyone. My name is Lucas Samaro. I founded Equilibrium Point with Grace. I'm the CEO. Grace is the CTO, and we also have with us Dan Talbot. Dan Talbot is a colleague from one of our past ventures, and an investor in Equilibrium Point, and also a car wash owner. So he's here to provide some industry perspective. Dan, introduce yourself.
Yep. Hi, everybody. Dan Talbot, owner of Wash Wax and Wheels Car Wash. Good to be here.
Where is it, Dan? Where's the actual
it's
location?
in Methuen, Massachusetts.
Oh, okay, cool. So if anybody's up and around Methuen, swing through.
Yeah,
shameless plug. Thanks.
Thanks, Mark.
Next slide, Grace.
Okay, great. Here we go. We were. Oops. Here.
There you go. Yeah, so Dan, Grace, and I actually have worked together before for quite some time. I was the founding CEO at a company in Danvers, Mass, by the name of Eliza Corporation. Eliza was a patient communication and remote monitoring platform focused on health plans and disease management companies. We bootstrapped that company. Grace and Dan were among our first employees. Grace in technology, she ended up running our engineering team and quality assurance teams, and Dan was in business development. And we ran it until 2017, when a publicly traded company in data services and analytics acquired us. And shortly thereafter, Grace and I started kicking some ideas on how we might apply some of our cloud expertise and experience into the areas of IoT, and sort of simultaneously with that, and unbeknownst to us at first, Dan was investing in some car washes around the New England area. And I'll let Dan tell a bit of his story in a few minutes, but the notion was that these would be sort of hands-off businesses. You could invest some capital, charge a nice price for these automated car washes, and all would be happy and profitable. And it turned out, once he got into it, that the car wash business is anything but hands-off. There's a lot of different equipment, some of which doesn't always talk to each other effectively, and the operating environment is really, really challenging. You've got water, vibration, noise, temperature extremes, and the expectation from customers that you're up and running essentially 24 hours a day, 7 days a week. So we studied, the three of us sort of kicked off a little business and technology case study, and it just struck us what a great use case the car wash business was for remote monitoring and learning and wireless sensors, and in particular, the Helium network. There's a lot of car washes around the country. Pretty much every town has several. They're geographically dispersed. More and more these days, kind of like Dan, one owner will own more than one, will own a few to several. So having to go back and forth to the washes and checking on whether or not systems are up or down, or supplies have been depleted or not, or customers are happy or unhappy, was really, really challenging. And the industry economics are really interesting, and they make remote monitoring really valuable. So it's a high fixed cost, high contribution margin kind of business where if you're up and running, they're really, really profitable. If you're down, it turns negative really, really quickly. And Dan has a number of experiences where his car wash was down for several hours at a time, and he was basically just losing money sort of hand over fist and not even knowing it. The interesting thing about some of these, about the car wash business, and as it relates to LoRa and Helium, is some of these sites have Wi-Fi, many of them don't. When they do, it's frequently separate from the operating room where the sensors need to be, and frequently it's in a completely separate building. So a lot of our customers have a convenience store or a gas station where the Wi-Fi sits, and the car wash is several hundred feet through some thick concrete out the back. And so we were sort of pretty chronically having challenges with Wi-Fi signal and the uptime of our own systems, which was a problem for us. Grace, next slide.
Sure.
If you would.
Here we go.
Yeah, so a bit about our capabilities, and this really started, with the ELIZA story back in 2010, 2011. We were a very early adopter on AWS, and we've taken that capability and extended it into the IoT realm. And so we know how to scale, we know how to design systems using Amazon services, and we know how to scale them. At its peak, ELIZA managed patient records and patient communications for nearly 80 million people across the United States. And with a similar kind of expectation for throughput and uptime that our current customers expect. So we know how to get out in front of some of these services. We're early adopters in serverless data lakes. We're doing a lot of interesting work in machine learning. We're starting to get into predictive maintenance for the equipment that we monitor, for example. And a big part of our offers is not just the sensors and the platform itself, but the analytics around uptime, causes of downtime, preventative maintenance, like I mentioned, things like chemical usage. These car washes, probably their number one variable expense is the soap and the different chemicals they use. And there's pretty wide variability. So we came up with a really neat solution where we can wirelessly monitor the chemical levels and actually correlate that back to the cost per car for different wash packages, and people can sort of adjust that and view it in real time. We let our partners brand the technology, both the hardware and the responsive mobile application that our customers use to check on the status of their operations and get alerts. We have a really active roadmap. This year, we're working on IoT at the edge, some computer vision and defect detection technology, damage to cars and liability from customers in these washes is a pretty significant issue for these car washes. And so we're coming up with some neat automated solutions for that. And we're getting into real-time asset tracking. There's a lot of shipments that go back and forth between the distributors and the car wash operators, and we're working on helping track the inventory levels and where those supplies are at any given point in time. At this point, we've done integrations with literally hundreds of different types of sensors, both our own and third-party sensors. We're essentially agnostic to that. And a really cool aspect, and something which is really useful for our customers, is even though they buy their equipment from different vendors, and in Dan's case, in 2 of his washes, he purchased those systems as they were, as opposed to building it from a greenfield. We've come up with a way to integrate all of that monitoring and the data and the alerting in one common interface. So no matter pretty much wherever the customer buys their equipment and their supplies, they can get one integrated view into what's going on at their car wash and get alerted on an exception basis on thresholds that we help set with them. So they basically know, they know what to worry about when, and can basically relax if they're not getting alerts from the equilibrium point system. We've got our own controller design and our own gateway design. We source components, I think like a lot of folks who work on the hardware side of things, literally globally, some right down the street in Massachusetts and others, from Hong Kong. Next slide, Grace. So we're going to be doing a deep dive today on the car wash use case. It's not our only use case. We're doing a lot of work back in our original home domain. So in healthcare, again, in remote patient monitoring, and there's a lot of interesting work going on in managing large populations of people with chronic conditions and figuring out who needs more intensive support from clinicians and who can be sort of managed and monitored with technology remotely. Now we're doing things in agriculture, crop monitoring and crop optimization. We actually got into the water treatment segment because of the work we were doing in the car wash business. And we see a lot of that where one given market will use an aspect will then lead us into another segment, which has been pretty fun and pretty successful. So car washes often have their own water treatment systems in the wash because the quality of the water is a pretty direct determinant, if not the main determinant of how the car comes out of the other end of the car wash in terms of spots and whether or not you get the soap off. And so we started doing water quality system monitoring and water quality monitoring and tank level monitoring for commercial installations and commercial buildings, including car washes, and that got us into some residential applications as well. And then hospitality, hotels often have their own water treatment as well. That got us in the hospitality area, and hospitality and hotels are essentially a specific use case of buildings. So we've been doing a fair amount of work in the building management space too. Next slide, Grace. I'll let Dan describe this slide. So this is actual data that represents some of the pain he was feeling. That total count up there, total equals 140. That's the number of system outages he had in a 6-month period when we stood up the system at his first site. So Dan, why don't you talk a bit about this?
Yeah, thanks, Luke. Hello, everybody. So just to piggyback on what Luke said, I'm the owner of 3 car washes. Well, 2, we're about to break ground and build a new one. We purchased in the fall of 2017. It was an attractive investment for us for a few different reasons. There are 2 types of car washes at a very broad level. One is the tunnel where a car gets on a conveyor and goes through, and others that are called in-bay automatics, and that's what we purchased. That's where you drive up, you put your card in, and you drive in, and the machine actually goes around you. The first car wash we purchased in Methuen was a touch-free, and my business partner and I were looking at this as an active investment, but also hands-off. There are no attendants needed, and it can run 24/7. And so we quickly found out what some of the challenges are in the industry. Before I get into that, I will say that the car wash, it's a great business. It's if you like working with your hands, there's a lot of mechanical work that can be done. It's great talking to customers, and if you're dialed in, if your systems are all dialed in, it can be profitable. But if they're not, that can cause some pretty serious issues. Luke had shown some of the data up here. The 3 biggest things for us that were I would say sort of the top 3 problems. One of them is outages. So an outage could be our point of sale system. It could be internet unable to process credit cards. website. People aren't able to, log in, buy a gift card, as well as the control system. And the challenge there is that any one of those things can go down. And we did have issues where some of those systems did go down, and we didn't know about it for several hours. And this industry is really a make hay while the sun is shining type of industry. You're not getting a steady flow of business every day. It's typically in the winter months for us up in New England, when there's a lot of snow on the on the ground and salt, et cetera. And so having an outage could cost $500 to $1,500 to $2,000 per instance, and we had no visibility into that. The other area is chemical usage. So there's limited insight into the amount of chemical that's in the tank, we found, and we also had limited visibility into the variable costs, or the one of the key metrics we use is the cost per car, as well as we didn't realize this until it happened to us. Things can clog, and so the chemicals, especially with the touch-free wash, it's all about the chemicals, because there's no brushes, there's no friction, and so if you've got an injector tip that's clogged, you could have a lot of unhappy customers with their cars soaking wet or left foamy, and then the temperature. So we live up in New England. Just a very sort of quick anecdote. We purchased in 2017 in the fall. That winter was, I think, one of the coldest stretches of single-digit weather in history. And we had some pretty catastrophic failures of the system. At one time, our bay door had frozen stuck, and all the systems were froze, and so we had burst pipes. And I remember at 11 p.m. working on one of these systems, and I think it was 2 degrees, and I literally had icicles hanging off my elbows. And so yeah, so there are a lot of things that can go wrong, and part of what we were finding is that there were really limited ways to monitor and track all of that, and so that's when this use case came up. Next slide, please. So in addition to learning a lot about the industry, as an operator, there's some interesting dynamics and transitions taking place in the industry itself. I think if you looked back 10 years, a typical car wash operator would probably be family owned. It would be a long tunnel that required attendants and people that would dry the cars off, and so would require a lot of staffing, up to 5 to 10 employees. And what I see now, if anybody is familiar with the self-storage industry, I see a lot of parallels to that, to what happened to that industry maybe about 10 years ago now. We're seeing that as an industry, it's certainly caught the attention of investment professionals, and so there are many more operators that are similar to us, where they're looking beyond just a single site, looking to go to multiple sites. There's a lot of more car washes being built, and that means more competition, and that means you have to be a lot more efficient in what you do. That said, for all of those changes, what we found really is that the technology has really been lagging in that regard, and so I think Luke had mentioned that there's multiple manufacturers. Just to give you an idea, I wrote a list before this of all the different systems that we have to keep track of, and it's your in-bay equipment, the control panel, a compressor, water heaters, a floor heat in the furnace that goes with it, a bill changer, vending machine, vacuum, tire shine, the bay doors, the security system, the cameras, and previous, prior to EQP building this system out for the car wash, I would say 80% of those had no monitoring at all, and others did, but it was in two different systems, and none of them talked to each other. So the industry is changing, and I think there's really a need for the technology to meet that change. Next slide, Luke.
Just a heads up to the EQ team, just want to be cognizant of time. We probably got 10, 12 minutes before we jump into questions. So just keep that in mind.
Yeah, all right. I'll go really quick then. The solution itself, and I think Graciela is going to give a demo, so I won't go into too much detail. The thing I like about it a lot is it's really dead simple. The sensors, they're wireless. They can practically go on any system that we have. I get an envelope in the mail. It's got the sensors. I put it onto this is a chemical level sensor. I turn the button that says turn on, and then it shows up on my phone in my dashboard. And so in my dashboard, I've got a number of different monitors. It doesn't matter what system I'm using. And one of the other nice things is that it can be added to very quickly. So we had an issue where the floor heat wasn't working, and I said, Graciela and Luke, could we have a sensor that would be able to tell on the heat of the pipe if it's going to be if it's on or not? And so next thing I get in the mail is this cool little sensor that you put a zip tie around the pipe, you turn it on, and it's good to go. So most of the sensors are wireless. That's been a big advantage for us. And the maintenance is really simple. EQP will let me know if there's a battery. The batteries last a long time, over a year, but they'll know at their system if the battery is getting low, and then they'll just ship out a new sensor, plop it in. I put the old one into the box and mail it back to them, and there's no disruption. If we get a different size container, we just give them the measurements, and they'll configure the sensor. We can even use the same sensor for the same thing. So it's really convenient. It allows me to spend more time with my family because I'm not driving to the car wash all the time, trying to figure out if we've got enough chemicals for a long weekend. And it crosses all of those, the different systems that we need to monitor. So it's really been a game changer for the operations. And as we bring on more car washes online, that's only going to get more important. And then the final thing I'll say is the being able to track some of those variable costs. There's a really killer algorithm that's been created to be able to provide that level of detail, so that we can make adjustments as needed and have insight into that.
Yeah, so I'll go. Thanks, Dan. I'll go through this real quick so we get to Grace's demo. So I'm seeing folks are asking about pricing and types of sensors. If you go to our website, the pricing is really flexible, because one of the things we learned from our early customers is all these sites are different. They have different priorities. So it's basically set up so each owner operator can pick whatever type of sensor they want in the quantities they want, depending on how many locations they have. And there's an upfront setup charge based on how many sensors they're going to utilize, and then a monthly monitoring fee essentially. And they can go month to month and just try it out. They can do a 1-year deal with a prepayment, or a 2-year deal with a 2-year prepayment for a discount. And then the monitor refreshes and the battery replacements are included with that. And to Dan's point, the sensors show up in a shipping box pre-configured to your equipment, and then you download this responsive web app. And shortly after you turn the sensors on, it'll light up with the icons for the sensors, the specific sensors you purchased. Next slide,
Luke, a quick question for you on this. Maybe Grace is about to get into this, but so for the LoRaWAN sensors, are most of these from vendors in the ecosystem, or are you building these from scratch for specific deployments?
Grace, I think it's a bit of both, but Grace, I don't know if you have any numbers on that. Yeah, we have, for example, and here showing in the catalog, we have a suite of 12 sensor types that we built. Dan is showing them. Look at that. That's our briefcase. of sensors. So these are mostly all the models that we have. And we can, thanks to Helium, honestly opens the door to the marketplace. So now we can cover hundreds of different types of sensors and systems that honestly were still not a large manufacturer, and we are not being able to deliver them all and manufacture them all. So this helps us to extend our capabilities in terms of other use cases that we can cover. There are hundreds of LoRaWAN sensors all over the world, some made here in America, others in Europe, Asia, and some of our customers want to pick the sensors themselves. If you plan to work as an IoT reseller, you can pick your own sensors too, and we will integrate them totally transparently for you in our platform.
Super cool.
And this, I'm going to show you in the demo how the mobile app looks like. Also, it's a desktop application as well. And maybe we should start with the demo, correct?
Yeah.
So
Yeah, let's see the demo.
Yeah, let's see the demo. So we will start first talking about where we are going to put the sensor that we are going to demo. So you have an idea, where is the car wash of them? Here we go.
So here in New England, we have some pretty brutal winters. One of the key systems that we monitor is the temperature in the wash bays. If we have a door frozen shut, the customer can't get in, that's pretty bad. If we have a door frozen open and the water system's freeze, that's even worse. So as soon as the temperature goes down to a certain threshold, I receive an alert right on my phone and we can take care of it right then.
Okay, so we are going to today register a sensor, a temperature sensor, and I will show you what happens under the hood. For Dan, the only thing that he only needs to do is enter on the bay that we just showed you and locate the sensor. That's it.
And sorry, just I want to give some context for some people who might not know what this is. So this is the Helium Console. So you can see the URL there. It's just console.helium.com. And so this is a web interface to basically managing devices on the network. It's entirely free. And this is what you use as part of the Helium network to deploy sensors. And as Grace will sort of walk you through here, they've done a fantastic job of using the, I hope is Dal on this call? I had a product. He's probably just ecstatic looking at your usage of labels here. He's going to be quite pleased at this. So anyways, this is console. If you don't have a console account, certainly sign up if you want to deploy some devices, but sorry to cut you off there. I just want to make a note of that.
So the only thing you need to do is just buy your sensor. Today I will demo the Dragino sensor. It's a temperature and humidity sensor that Dan has located in his base. He's not using the Pro, he's just using the ambient built-in sensor to locate on the bay. So the only thing you need to do, just plug it in there. We do the rest. And I will show you what we do because that's the fun part, what is under the hood. So the sensors come with this QR code here that you can learn from that, which is the device identifier, the application identifier, and the application key. All the worldwide manufacturers work the same way. So when you go to the Helium console and you add the device, you can incorporate here the device EUI, the application EUI, and the application key that was provided. If we put our sensors that we manufacture, we can use these device EUIs that Helium console provides. So if you are a manufacturer of a sensor, you can use the IDs that Helium is providing in the console. So I will show you the one that we just installed for Dan, which we call TEM14. And as you see here, we added a lot of what a field says labels. So labels are just metadata from the sensors that tell us where the sensor is located in the world. In this case, we know that it is located in our customer 11, which is Dan, Wash, Walks, and Wheels in Methuen. Dan has more than one location. So this is his customer, and this is the location 11, which is Methuen. And also, Dan has a hotspot from Helium in that location. And we have our own ID to follow up on that for the rewards program that we have in place. So there are some car wash owners that they don't have spots from Helium because Helium already covered the area. They have very good coverage, so they don't need to invest on that. And in the case of Dan, it wasn't enough coverage in the area, so he got one hotspot from Helium. And also we need to put the system type. What is the system measuring, monitoring? In this case, is temperature. Once we do that, as you see here, you can see in the console the packets that we were transferred. So in the last 24 hours, we already transferred 72 packets of data, readings of temperatures in the last 30 days and all the time so far. And also here you can see, clicking in DC used, the amount of data credits that are going down from our wallet here. These are data credits that they cost less than $1 per device per year, depending on the frequency that you are transmitting the readings. In the case of Dan, I think our equation is much less than $1 per year. And the other interesting thing, the most interesting of all labels, is this one that says here AQP1. So because this holds what we call the integration. We are integrating the Helium network with our own equilibrium point platform data lake powered by Amazon AWS services. And what we do with this link, AQP Helium 1, is called a topic. If you enter our Amazon console, we can track the data, what we call data provenance. We can see the data that started in the Helium console right here with 1014 device and goes into the MQTT integration. And see here is AQP Helium 1. And you can see here the temperature, D0 is the temperature, D1 is humidity, D2 is voltage. This is not 1014, by the way, this is another soil sensor that is not yet installed. That's why you don't see any temperature here. Temperature you see, but you don't see any humidity. But if we look, maybe we found a 1014 here. Here we are, see 1014. And we can see here, D0 is the temperature in Fahrenheit. This is the humidity in percentage and the voltage of the battery. So we know that's what Dan says, that we can alert him if he's running out of battery, so we will set the replacement. So if we go back to the Helium console, we also attach a function in this integration. So by the way, you can get any integration with your own cloud. If you have cloud, you can do, for example, as we did, an AWS IoT core integration. You put your access key in Amazon, your secret key, your region, and your topic, like our topic, EQP Helium 1, and you will be connected with your own platform. We can do that for our customers as well. If they have their own platform, we can integrate directly with them. So this is how you do integrations. And going back to the device, let's go back to 1014. We can also see in this label, AQP1, a function attached that is the Dragino function. The manufacturers of IoT, they send the packets in a certain format. This is the format that they send the package, is a text format that needs to be decoded, and you get finally the hexadecimal code for the payload. And Helium provides a very interesting testing platform here where you can write your own decoder. These decoders for the most common devices are already provided. Some of them are in GitHub, and if they are not, you can ask us and we will create a decoder for you. And this is the way that Helium platform here, the console, provides a way to, this is in port 2, and I know because I can see the payload when I arrive to the cloud. See, I will show you that. So this is how the payload arrived to our cloud via a service that is called Firehose, and see that this is the payload that I'm now trying to decode, and this is the port 2. And here you can put port 2, and voila, you get the format readable, human readable, in what we call JSON format. And this is the format that I show you that arrives here into our equilibrium point data lake. Once that it lands here, guys, the next step is looking at the dashboard that could be displayed. I put it in a format of a mobile phone, but could be displayed in a desktop. Here is dance. And as you see, the only thing that you need to do, you put the sensor in the bay and you get this application in your phone. We will give you the link to the application, of course. This is the link, mywash, eqpiot.com, and some hash. And here is the temp bay 2. That's where Dan's located the sensor. See, you can see the history in the last 30 days, 7 days, and 24 hours. And you can see here, see this drop in temperature didn't happen. Good Lord, that we have 24 Fahrenheit again. No, this was because in the decoder, we forgot to see here the temperature. We now multiply by 9, divide by 5, and add 32, which we convert the manufacturer that was sending the temperature in Celsius to Fahrenheit. We forgot to do that. So as you see, the application is completely transparent. If you do a math error somewhere, you will see it in your tracking here. Here is the day that we figured out and we correct it to Fahrenheit, okay? So as you see, it's very easy to configure. We can do it very fast for you in the same day if you give us a sensor. And as you see, we can monitor all types of systems as Dan was showing. This, for example, a very interesting one. This is a container of pre-soak, is a chemical, and you see the pattern. That is very helpful for the customers because you can see how they refill the tank. It goes down, 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 down. They're running out of chemical, and the operator gets the alert, and they immediately refill, so they never run out. Look here, the operator let it go this day. Let's see if we can see it in 24 hours. See, it went a little down, almost getting into red, into critical, and immediately they refill it. Okay, so this is what we call a call to action application. So the people, see Dan is showing there on his phone, the people can act upon it. So if we see that you are going to a warning, the bubble will go yellow, and if you are letting it go and if going beyond warning, you will get the bubble in red. And that's the way that you can remotely operate your wash. You have other systems here. Look at the vacuums. The vacuums are very, very interesting too. It tells you how many minutes a day per vacuum you are selling, and you can convert in dollars the minutes. They have a conversion. Some of them are coin operated, some of them are credit card operated. And you can also see, for example, the control systems. See that red lines indicates that they have an outage. The control system is the system that operates the entire automatic wash, the machinery. And see, you can see here how many minutes it was down and when, so customers can follow up on their operation. They can improve the training of the operators, and they can improve the overall cost effectiveness of the business. And I think that Dan, after using our application, increased his profits a lot. And you can see here, you can follow the revenues in 7 days, 24 hours, 30 days. So you can track what is going on as you go day by day. So you can also add this another interesting one, the coin machine. A lot of people like to change cash for coins so they can go on the vending machines and buy stuff for the cars. And they love it. And it's important that they are on, but they always have problems, these machines, as you see, the reds. So this alerts you, so immediately you go back there and you put them back to service. Having the question, to delay this more because I know there are questions there. So please go on.
Grace, if I could just add, I think it's an important point. So some of these things might not, you might say, why are you monitoring a bill changer or a vacuum? It's like a death by 1,000 cuts. When a customer comes to the site, we want to make sure everything is working for them. And so if the bill changer isn't taking bills, they can't get quarters, or if the vacuum's busted, the overall experience is not good. And so it's just been really nice that we're able to very quickly get an alert, before pretty much before any customers are impacted by an outage. So yeah, it's been a game changer for us.
This is fascinating. I mean, I have the pleasure of seeing, hundreds of use cases on top of the Helium network. This is sort of entirely unique, which is super cool. Okay, I want to do some questions, and thank you, Grace, for that presentation. I think, manage to find the hotspot in Explorer that is at your car wash, Dan. If you're open to it, I'd like to put it on the screen and show people like this, the data traffic. Is that okay with you guys? All right, let me see here. So we're going to share screen. I'm going to
let me stop my share. Here we go.
And so I'm going to put it in chat so people can, because this is what ties the whole thing together, right? The idea that you've deployed coverage, or you're creating public coverage, and then more importantly, you are using this. Can people see the screen over here? Yes, no? People seeing screens?
See it?
Okay.
Yes,
All right, so I'm gonna put the link in here. And again, like, it's a public network, it's a public blockchain. You can see what's out there. So, the hotspot that's at Dan's car wash is called the alert-led poodle. And, if you scroll down here, you can see the usage, right? You can see packets transferred, we're sending data credits. Grace showed this inside of console during the demo. But it's just so damn cool, right? This is the business logic flying through, not the business, the raw data that gets transformed into the business logic by Luke and Grace and the team, and it's just working, right? You're sending data credits, or sending packets, spending data credits, earning HNT for the actual packet transfer, which is great, and then you're also earning HNT obviously for things like what are we doing here? We're witnessing, right? So this is like the complete picture, and this excites me and the team the most, I think, because we're starting to see this more and more, where companies like EQP are deploying coverage for their own use cases, creating big chunks of public coverage. And you can see the natural progression where Dan starts to deploy this at 2, 3, 4, 5, 6 car washes, and the EQP team continues to sort of grow their footprint, and the entire network benefits. So it never ceases to excite and amaze. Okay, so with that, if you want to toss your final slide back up on the screen, Grace, just so we have a backdrop for the Q&A. We can do about 5 minutes worth of questions. I think we answered most of them during the convo, but I'm going to toss them up here, and I'll start. Let me just pull some questions real quick for the team.
Yeah,
and again, if you guys don't get your question answered, definitely email myself. I'm just mark@helium.com, or info@eqpiot.com. So let's see here. So I think we talked about this, but Senecal Capital Management, company, not a person, can multiple owners aggregate all the data for a holistic and simultaneously per location, or multiple locations, right? So if you got 5, 10, 15 car washes, are you giving people a single view of this?
Yeah, so the responsive mobile app itself is designed for each location, but we have built reporting for people that aggregate different locations, more for trending, not for real-time alerting. So if they're interested in looking at, does site A use more chemical than site B? How much is that, and what's going on there? That sort of thing we've done.
Cool. Okay, thank you for that. So Christine is asking, does EQP have a solution for communicating with Siemens PLCs? Not a terribly irrelevant question. Does that ring a bell?
Yeah. Grace, I don't know if you know, but I think we've seen every PLC on the market. I know for a fact some of our customers use Siemens hardware, so my sense is yes.
Yes, it's Siemens, or the other big one, which is the name, Lucas, the one that we were electric, which is the big one, the French company. I think they're both related with Siemens.
Okay.
So yeah, any PLC in the market is just a signal that we send.
Schneider. Yeah, someone just answered for us, Schneider.
Oh, Schneider. Yeah.
Schneider Electric, that one. I couldn't remember the name. Schneider Electric. Yeah, the majority are from them, from Siemens. And yes, you can, this is 2 ways. I mean, we can read information from the sensor, but based on the information, we can act through a PLC to any other system. For example, you can stop a conveyor at the car wash, or any other operation that you want to program in the PLC, we can send the signal to it.
Awesome. Okay. So PLCs, you work with them, you're ready to integrate with them, no big deal. Another question from Christine. Can you purchase, so someone mentioned the WizBlock Rack development kit, which is a great development kit for working with Helium. I actually happen to have one right here in front of my person. So I'm not, the background might prevent it from showing itself. Hold on a second. We almost had it. Travis, if you're on the call, you're going to kill me because I can't show this. Anyways, there are maybe Emily or McKenna can drop a link to the WizBlock Rack dev kit, the Helium dev kit. It's a great piece of technology to prototype on if you don't want to buy an off-the-shelf sensor. Okay, let's see here. Ryan Smith, is there no sensors that, yeah, so basically the question here is, I think you answered it, Luke and Grace, but why, LoRaWAN versus Wi-Fi for the core sensor functionality, essentially?
So you go, Lucas?
Yeah, sure. Yeah, I think, well, a number of reasons. One is just coverage distance. Many car washes don't have Wi-Fi at all because they're standalone robotic 24/7 operations without staff, so they don't need it. And then the ones that do, we found the coverage to be pretty spotty. It's often not maintained great, and it's often separated from the operating room. So our sensors are inside the actual bay with the equipment, and the router, the wireless coverage is usually either a few rooms over, and in a lot of cases across a parking lot. So that and just low power consumption. So this is like the perfect use case for us, where we're not transmitting a ton of data, and we need the batteries to last as long as possible because it costs us money to refresh them. So those are the primary reasons.
Plus, if you just use Wi-Fi, you're not creating a public network, right? You're not extending the Helium network. You're not providing a utility to the world. You're not mining HN2. So it might be worth it just for that. Okay, so we'll take a couple more. We're running short on time. Let's see here. So Ryan Partridge, big fan on Notepad. I appreciate that. I'm sure Grace does as well. Let's see. And I'm sorry if I don't get to all of these. So question from Leon Botha. Do you have any reboot functionality via LoRa? I'll take that. So typically your sensor is going to give you a fair amount of functionality and flexibility when it comes to the firmware. So with a LoRaWAN sensor, you're going to be programming in some retries and the ability to sort of reconnect to the network in the event that it sort of loses connectivity outside of the window that you expect. Grace, does that pretty much line up with how you operate? Yes. Anything to add there?
Also, you can do over the air, you can change the interval of the readings. That helps a lot because, for example, sometimes we are very aggressive. We are reading every 15 minutes, and the customer said, "You can slow down. We don't need every 15 minutes. We need every hour the reading." And then you save battery, you save data credits, and you can do that remotely over the air. Through the Helium Console, by the way, in the Helium Console, there is a way to send the information to the sensor and to change the interval, for example. Or
the downlinking, there's an API for that, and you can do it from directly in console too, and through AWS, which is great. Okay, so Lampy's asking or stating he sees the flexible pricing on the EQ site. Can you roughly break down the costs of someone like Dan's needs? I'm going to say go ahead and email the EQ team or EQP team for that, just so we save some conversation. I'm sure Luke and Grace will be happy to walk you through that. Let's see if we can take one more. I guess same person. What's EQ's growth strategy for the solution? If you're up for it, how many car washes? If you're up for sharing, what's your footprint look like currently?
Yep. Yeah. So our growth strategy, there's a few different legs to it. Actually, one of the strongest has been referrals. So we do a good job for people like Dan. Dan referred us to one of our first customers out in the Midwest. They referred us out to Texas. We also have distributor relationships. Exact count on car washes, it's somewhere under 100, more than a few dozen, but less than 100, I think, as of a few weeks ago.
Awesome. All right, so how is a hotspot the car wash without internet access? How does that connect to the network? I mean, I guess, if there's no backhaul for a hotspot, do you have a solution for that, assuming there's no Helium coverage?
Grace, you want to take that one? I don't think we run into that.
Say again. What was the question?
Yeah. So the question,
no
Grace, is
at all.
Right. If there's no, Ethernet to plug a hotspot into or Wi-Fi network to connect it to, are you using cellular backhaul, or do you just not consider that part of your addressable market just yet?
Yeah. I mean, we don't have that situation. Usually, all the car washes do have an internet connection, but that's another thing that we're doing now with Helium for people that do not have access to Wi-Fi, but the coverage is somewhere else in the neighborhood. You can transmit, so you don't need to have a Wi-Fi connection anymore. So that was another advantages of having Helium too.
Yeah, and so Carl Armstrong mentioning 4G modules. Yeah, so there are a few manufacturers that are starting to produce 4G and 5G backed hotspots. I know RAC is about to produce one. You've got Long AP out of the EU. I know the Seed team and Brown/Gemtech are working on that too. So there
yes,
will.
The problem is that 4G LTE is a little expensive for the car
Sure.
wash owners, so that's what we're trying to avoid that. But definitely, you can add a module, LTE module, if needed.
Sure. Okay. All right. So we've got to cut it off here. We're about at time. Well, sorry. Last question from Arrow Schill is: apart from AWS, can we integrate other platforms like ThingsBoard with Helium Network? Absolutely. Yeah. So if you go to console, you will see integrations, and we have about 10 pre-built integrations at this point. So if there's not one, we can build one, or you can request to have it built. And if you can't, we can do HTTP or MQTT directly. So with that, I'm going to say thank you to Luke and Dan and Grace for a fantastic presentation. This is one of the most interesting ones I think we've seen. Their email is info@eqpiot.com. Any last words from the team? Anybody want to toss anything else out there?
Nothing but thank you, Helium. Thank you, Mark and McKenna and the team for having us. Thanks everybody for participating. Great. Thanks so much.
Yeah, very excited to be part of this network. Go Helium.
Yeah, we are.
Go HTTP.
Yeah, we are very pleased to have you. Okay, well, we'll see everybody here on the next Uplink. I really appreciate your time and have a great week. Thank you.
Bye-bye.
Bye, guys. Bye.